Hello there, this is Miss Nakayama, and today's lesson is 8.2 Inconsistent and Dependent Systems and Their Applications. So what we're going to talk about today is continuing with the previous lesson. We're going to use Gaussian elimination to solve systems that without unique solutions. That means they have more than one answer, and we're also going to apply Gaussian elimination to systems with more variables than there are equations. So keep in mind that we can use Gaussian elimination on systems with 3 or more variables, but sometimes we can't always get it in that row echelon form. And that would be perhaps if there's no solution to it, it's inconsistent, or if it has infinitely many solutions and is dependent. So we're going to do the best we can to interpret those results. So let's get started. So number 1, use Gaussian elimination to solve the system below. So I'm going to put that in our matrix form. So we know the first row is 1, -2, -1, and -5. And then 2, -3, -1, 0. And then 3, -4, -1, 1. All right, and so remember from our previous lesson, we're trying to get 1, start with the 1 up here, and then get zeros below it. So I'm going to use that 1. I thankfully already have it. And I am going to multiply this row, because I'm using this 1 right here. I'm going to multiply this row by the opposite of that. So I'm going to multiply it by -2 and add it, multiply, and then add it. So remember when we talked about this before, whatever row I'm replacing goes second. So that's row 2. And I'm going to multiply row 1 by -2. And when I start that, remember that I like to, let's go here. Always write that row that I'm multiplying so I don't get messed up. So I'm going to go ahead and write those. 1, -2, -1, -5. That one's not going to change. Now this row, -2 times 1 plus 2 is going to be 0. -2 times -2 is 4, plus -3 is 1. So I'm back over here. -2 times -1 is +2, and +2 minus 1 is 1. -2 times -5 is 10, and 10 plus 0 is 10. Now I'm going to go to my next row, bottom row, okay? And this time I'm going to replace row 3, so that's what we write second, and I'm going to multiply row 1 by the opposite of 3, and that, of course, is -3. So -3 plus 3 is 0. Then I have -2 times -3 is 6. 6 and -4 give me 2. -3 times -1 is +3. +3 and -1 is 2. And then -3 times -5 is 15. And 15 plus 1 is 16. Okay, so now I have a 1, and now I need to, so my first column is complete. I'm on to the second column, and that's to get a 1 right here, and now I'm trying to get a 0 down here. So that means I'm going to multiply, I'm going to replace row 3. So I write that second, and I'm multiplying the second row by the opposite of 2, which is -2. So that's going to give me, again, first row is not going to change. Second row is not going to change. But my third row, 0 times -2 is 0, plus 0 stays the same. -2 times 1 is -2, plus 2 is 0. And I get the same thing again. And then, of course, I get -2 times 10 is -20, plus 16 is -4. So remember, how did we go from here to here? These just represent coefficients of a system of equations. So that means that this bottom one says that 0x plus 0y plus 0z is equal to -4. Or in other words, 0 is equal to -4 because that vertical line is like your equal sign. Well, that is a false statement, so that means there is no solution to this system. So you got to pay attention to that. And when I showed you class calc on the last lesson, the goal of that was for you to have a great opportunity to check your answers. Sometimes you will use it alone, but you also need to do these by hand. So make sure you're doing that and practicing. All right, so look at this guy. Use example 2, use Gaussian elimination to solve this system below. So again, I'm going to copy down the system. I already have a 1 in the upper left-hand corner, so I've got 1, -2, -1, 5, 2, -5, 3, 6, and 1, -3, 4, 1. So starting with, I'll go ahead and start with that middle row. I got a 1 where I need to. So that middle row, I'm going to replace row 2. So I'm going to add to it, and I'm going to use row 1 because we always use the 1 in that column. And I'm going to multiply it by -2. And so that's going to give me, remember, I'm going to make the first row stay the same. But now my second one, so I'm looking at -2 times 1 plus 2. And that, of course, is 0. And then I'm going to have -2 times 2 is 4. And 4 plus -5 is -1. -2 times -1 is 2. And 2 plus 3 is +5. And then -2 times 5 is -10. And -10 plus 6 is -4. And now I'm going to go to my bottom row. And again, I'm replacing row 3, so I write it second. And I just have to take row 1 and the opposite of it. So it's going to be negative row 1. So -1 plus 1, I'm using the top and the bottom, y'all. I take the opposite sign and add it to the bottom row. So 2 plus -3 is -1. And 1 plus 4 is 5. And 5 plus 1, no, -5 plus 1 is -4. Okay, so now I've got to, I'm going to leave that alone right now because I got to get this to a 0. Okay, you can go ahead and multiply everything by -1 if you want to. I didn't, okay, but it's okay. So I'm going to go take care of this bottom row and get a 0 right here. And so to do that, I'm going to replace row 3, and I'm going to multiply row 2 by its opposite and add it. So when I do that, top row stays the same, second row stays the same, third row, 0 plus 0, 1 and -1, -5 and 5, and 4 and -4. So this time I actually get a true statement, okay? But we don't get to say infinitely many solutions. So what we do is we're still going to take each of these other 2 rows and we're going to write the equations that come from it. So again, you could go ahead and change this second row, but I didn't, okay? So that's -y plus 5z equals -4. And the top row says x minus 2y minus z equals 5. And so what you have to do is we've got this bottom row of 0 equals 0. So we're now going to write x and y in terms of z. So I'm going to go to this second one, and I'm going to go solve it for z. So when I do that, I'm just going to switch the y and the -4. Negative y and the -4, and that's going to be 5z plus 4 equals y. Okay, and then I'm going to go take this equation, and I'm going to go plug in for y. So I had x minus 2y minus z equals 5, but instead of y, I'm going to write 5z plus 4. And then I'm going to distribute that negative, and then I'm going to combine my like terms. And I'm still, as I said before, y'all, we're solving for x. So that means everything else goes on the other side of the equation, and x equals 11z plus 13. So when you write this answer, okay, z is z. That was my bottom row that had the zeros in it. Then y was equal to 5z plus 4, and x is equal to 11z plus 13. So that is how you write an answer for infinitely many solutions. Okay, last example. Sometimes you will use Gaussian elimination to solve a system, and if you notice, this actually has only 2 equations, but I have 3 variables. So there's going to be an issue with that, and let's see what happens. So when I write my system, okay, I have 1, 2, 3, 70, and then 1, 1, 1, 60. So I need to get, I've got my 1 where I need it. I'm going to get this to be a 0. So I'm going to do my best to put it in row echelon form, and then you'll see what we do from there. So that means the bottom row is going to be replaced, and I'm going to take the opposite of the first row to do that. So that's going to give me top rows. I'm not replacing it, so it's going to stay the same. So take the opposite of the top row. -1 plus 1, -2 plus 1, -3 plus 1, and -70 plus 1. Okay, and this time I'll go ahead and change the sign of all of these. So I'm going to multiply it by -1, and those are going to stay the same, and I'm going to get 0, 1, 2, and 10. Okay, so this bottom row gives me y plus 2z equals 10. So we're always going to write it in terms of z. So solve it for y in terms of z. That means I just take the 2z to the other side, so y equals 10 minus 2z. But now I have to go up to this top one, okay? And I've got that equation says x plus 2y plus 3z equals 70, okay? And you could solve it for x. I'm going to show you kind of a different way. You can go ahead and put the y in there if you want to, but to help you remember, we're trying to solve for x. So I'm going to take the 2y and the 3z to the other side. So that's -2y minus 3z plus 70. And then I'm going to go plug in what y is, and y is 10 minus 2z. And then I'm going to distribute, and then I'm going to simplify. So when I write my answer, always z is z, y is 10 minus 2z, and z is x plus 50. X is z plus 50. And that is solving systems that have inconsistent or dependent, that are independent, dependent or inconsistent. If you have any questions, y'all, please don't hesitate to ask me, send me an email, but please, please, please practice. Thank you so much for watching, and y'all have a great day.